Vectors, Graphical Edition. Here are your priming questions. For vectors, as a quick reminder, the way we define it is as a vector has both a magnitude and a direction. So if we want to graphically represent a vector, we need a method for being able to show both the magnitude and the direction of that particular vector. The way we do that is with one of these arrows. And in this particular case, the head of the arrow shows the direction, and on the other end we have a tail, and the length of the arrow represents the magnitude. And so, for example, let's say we want to add these two vectors together. We have 4 steps for adding them graphically. We first need to add our vectors head to tail, and in this particular case, I'm not going to be adding more than 2, but you can add as many vectors as you like. And so I would organize it like this, and the order that you add them doesn't matter, and I'll show you that in just a moment. So once we add them head to tail, and you can see the head of one is touching the tail of the other. From there, we draw a line from the tail of the first vector to the head of the last, and this is what we're going to call the resultant. What you will notice is that the resultant's tail is at the tail of the first vector, and the resultant's head is at the head of the last vector. To get the magnitude of the resultant, we simply need to measure the length of the resultant vector, and then we measure our angle at the tail of the resultant using a protractor. And I'm going to keep my resultant there, and I'm going to add these in a different order, and what you'll notice is that the resultant is exactly the same. So the order does not matter at all. You can add them in any order you like, and you should still be able to get the same answer. So let's do some more practice, and let's not use this many vectors to start out with. We'll keep this will be good. Alright, so let's say we want to add these 4 vectors together. Again, the order does not matter. So let's just say we want to start with this particular vector. We just need to make sure we add them head to tail. So let's go to here, and we'll backtrack, and then we will go here. And now, if we want to draw our resultant, this was our first vector, so we went to the right, then we went down, we went up, and then to the left. And so, we would draw our resultant like this. And this is our resultant. From there, if we want to measure the magnitude, we do this like this. And let's say that that's going to be roughly, let's say 1.49. So we would say this is 1.49, and if these are 1 meter increments, 1.49 meters. And then after that, we need to measure our angle. So move this off to the side, and we measure it from the base. And there are a number of ways we can do this, and I'll show you bearings in just a little bit. But for now, we'll just use total. We can use total degrees, and I'm going to go and estimate that at around 40. We'll just go and say 45 degrees. And this is going to be at 45 degrees over here. That's going to be measured either from here or from the other side. I'll go more in depth about angles in just a moment. And as a quick reminder, the order doesn't matter. So I'm going to leave the resultant there. And I'm going to add my vectors in a different order now. So let's go down first. Let's go to the right, and then let's go to the left, and then let's go up. And again, you'll notice the resultant is exactly the same. And you can do this with as many vectors as you like. We can go and add more if we wanted to, but let's go and move on to bearings so I can explain more about the angles. Our angles require a frame of reference as well. You'll notice I was vague in the last slide because I wanted to be more specific here and now. And so I've drawn my final vector, my resultant, and I've also given where I'm measuring my angle from. And so I want to talk about frame of reference for angles. In this case, what you'll notice is that I've drawn the x and y axes that are appropriate for my particular resultant or vector, and I've measured from one of those axes. What you will most likely be doing is always be measuring from one of your cardinal directions, north, south, east, or west. Let's look at this first one. In this case, I'm measuring from north, and I am measuring east from north. And so the nomenclature that we use for this is this angle. Let's go and say that this is measured to be 52 degrees. Whatever the angle measurement is from here to here, the nomenclature that we use for this is, since it's measured from north and it's going east from north, this would be east of north. If we look at this one over here, we can see that we are being measured from the west and we're going north of west, so this would be north of west. Here we are measuring from south and we were measuring west from south, so this would be west of south. And here we are measuring from the east and we're going south, so this would be south of east. And so with this naming convention, the of direction, so in this case east of north, that means that's where we are measuring from, and the first direction is where we are going from that direction. So east of north, north of west, west of south, and south of east. Remember, the of direction is where we are measuring from, and that's going to be whatever cardinal direction you're measuring from. And then the first one is where you're going from that cardinal direction. So with this naming convention, if we look at these two vectors are actually the same, but they have different bearings. And so when you're giving a vector as a resultant for your answer, you need to make sure to tell me what the bearing is, and there will actually be two good answers that will receive full credit. So in this particular case, if we measure 60 degrees over here, this would be 60 degrees, and then we notice that we are measuring of north, and we're going east, so this would be east of north. And if this is the correct answer, that would be fine. And if the next person measured it from the east, they would measure 30 degrees from the east and going north. And so they would say 30 degrees north of east. And both of these answers would be correct. And here are your priming questions again.